Progress notes. May 2026. Finding the forgetting problem at the promotion boundary. One of the more counterintuitive things you can discover in a memory system is that giving it more memories makes it worse at specific tasks. That's what surfaced this week. We've been running a long horizon evaluation, thousands of problems tracked across sessions, with the system accumulating experience as it goes. The memory architecture is layered: short-term within a session, cross-session pattern recognition, and longer-term encoding. When a pattern proves robust across multiple problems, it gets promoted from the cross-session layer into longer-term storage. That's by design. That's how expertise is supposed to accumulate. What we found is that promotion is structurally lossy in a specific way. The cross-session layer carries two kinds of signals simultaneously. Call them positive and negative. Positive: this approach worked on structurally similar problems at this quality level. Negative: this approach looked promising but consistently fell short. It's a plausible dead end. Both pieces of information are present. Both get used. When a new problem arrives that looks like prior problems, the system retrieves both. Here's what to try. Here's what to skip. When a pattern gets promoted to longer-term storage, the positive half travels with it. The negative half doesn't. The longer-term store is a catalog of what works. It has no structural slot for what looks like it should work, but doesn't. The consequence showed up empirically on two specific problems. Both had been solved perfectly in a prior session. The system found the right answer immediately, with almost no search. In the new session, the longer-term store had grown. More patterns, more accumulated experience, but the cross-session layer had been partially drained by the promotions. On those two problems, the system explored hundreds of candidates before settling on a suboptimal answer. More memory, higher search cost, worse outcome. We isolated the mechanism. Both problems require navigating past a class of constructors that look highly relevant but produce wrong outputs. In the prior session, the cross-session layer had explicit negative signal for those constructors. We've seen these before on similar problems. They don't land. That signal pruned the search immediately. In the new session, the negative signal had been promoted away. The pruning didn't happen. The system had to rediscover the avoid list from scratch, and on these particular problems, rediscovery ran into the search budget limit before finding the right path. The phrase we use internally is scar tissue, the accumulated record of partial failures, rejections, and dead ends that tells a system where not to go. The insight here is that scar tissue from successful learning is being preserved. Those patterns made it to longer-term storage, while scar tissue from partial failure cross-task generalization is being lost at the promotion boundary. The system is keeping its wins and forgetting its specific near misses. This maps to something recognizable in human expertise. An experienced practitioner doesn't just know what works. They have a finely tuned sense of what looks like it should work but doesn't, built from specific remembered failures. A novice and an expert may share the same catalog of positive techniques. The expert's additional value is often the negative catalog, the dead ends that are specific enough to look promising but consistent enough to skip. That catalog doesn't transfer automatically by knowing the positive results. It has to be preserved explicitly. The finding is observation grade, 2 tasks in a 400-task evaluation. But the mechanism is clean, the regression reproduces exactly, and the fixed direction is clear. Carry the negative signal forward through promotion rather than dropping it. The architectural work is well defined. This paper establishes the derivation and hands the fixed shape to a future build session. What this isn't is a memory failure in the catastrophic sense. The system didn't forget what to do. It forgot what not to try first. That's a subtler problem, and in some ways more interesting. It means the quality of expertise isn't just about accumulation, but about what the accumulation mechanism selectively preserves at each transition. More patterns, same anchor. The anchor doesn't move. What changes is how efficiently the system navigates to it. Progress notes. May 2026. Finding what gets lost when memory promotes, and a more natural fix. We found a problem in how the system handles experience. Here is the concrete version. The system had been running a long evaluation. During that run, it accumulated navigational wisdom. Not just what worked, but the fuller record of what was tried, what partially worked, what didn't, and what the recovery from each partial failure looked like. That wisdom was living in a short-term cross-task memory layer, available as guidance for structurally similar future problems. At a certain point, patterns in that short-term layer proved robust enough to be promoted into longer-term storage. That's by design. That's how the system matures. But when a pattern promotes, the promotion process kept the clean result and discarded the navigational record. The what worked survived. The what was tried on the way there, including the dead ends and recoveries, did not. The consequence surfaced when we replayed two previously solved problems against the promoted state. Problems the system had handled perfectly, immediately with almost no search, now required the system to explore hundreds of candidates before settling on a worse answer. More mature state, more patterns stored, worse outcome on specific problems that had depended on the navigational record to find the right path efficiently, more memory, higher cost, worse result. The first pass at a fix was the obvious one. Carry the negative signal forward. Build an explicit list of what to avoid and attach it to the promoted pattern. Consult the list before each attempt. This is the wrong model. Think about how many times you've tried to insert a USB plug the wrong way. Hundreds, probably. Across your entire life of using USB devices, you have failed on the first orientation more often than not. But you have never, not once, stored Avoid Orientation A as an explicit rule. You don't consult an avoidance list before plugging in a cable. You try. It doesn't go. You flip it. Done. The failure is stored at near zero cost, just the bare fact that the first attempt didn't land. What travels with it is a correction reflex, not an inhibition catalog. The reflex fires after the first attempt, not before any attempt. The cost is one wrong try, not a growing list of things to check before every try. Applied to the system. The promoted pattern doesn't need to carry a list of constructors to avoid. It needs one cheap field, a correction pointer that says, based on cross-task experience, what tends to work after the first partial result on problems that look like this. File the first attempt as expected. When it lands short, the reflex fires. The search budget goes to the right place rather than re-exploring the full space from scratch. But the USB insight only fixes the immediate regression. The deeper finding is bigger. The reason the navigational record gets discarded at promotion is that the architecture treats cross-task experience as transient, something that lives briefly, informs a few tasks, and is cleaned up when the stable pattern is extracted. The navigational record's job is done. Promote the result, discard the workings. This is the wrong energy model for this kind of knowledge. Consider navigating a familiar room. You know where the coffee table is. You don't know it as a stored fact you retrieve. You know it the way you know how to walk. It's in the body. It's in the movement. It runs below the threshold of attention. You learned it through experience, including the experience of stubbing your toe. And that experience now lives as navigational posture rather than explicit memory. Nobody discards the stub your toe experience once the room is mapped. It's part of the map. It's why you navigate that corner differently than you navigate an open stretch of floor. The navigational record, the experience of learning, is not the working that produces the result. It is the result in its embodied form. What we're proposing is that cross-task navigational experience should work the same way. When a pattern promotes, the navigational record doesn't get discarded. It gets demoted, moved to a lower activation level, requiring less maintenance, available at lower priority. It persists the way the room map persists, not actively maintained, not actively queried, but available when the structure of a new problem calls for it. Evicted eventually, but only by disuse. If the pattern stops getting matched across many sessions, it fades. Not by promotion, not by a timer. The result? The system stops rebuilding its navigational history from scratch on every structurally familiar problem. The experience, successful attempts, failed attempts, partial results, recovery sequences, is part of the substrate, running passively, accessible without active reconstruction cost. Past experience remains present, not in a cache, in the body of the system's accumulated navigational knowledge, the way the room map is in the body of the organism that lives in the room. The immediate fix, the correction reflex, is well-defined and ready to build when the team decides to act on it.
From math to code to embodiment to existence,